All right, so that's enough of that. Because we only have like a couple weeks left, I wanted to still talk about some physics stuff, but this is actually pretty interesting just in terms of like an everyday kind of concept. So what we're going to do is we're going to depart from our discussion of momentum, and we're going to look at this thing here. Now, really all I'm doing, okay, all I'm doing here is I just put like a weight on the end of a string and I'm going to give it a little swing. How's that look? Okay? Not super complicated, but still something that you might be familiar with. I mean, if you ever played on a playground, you've probably swung on a swing. Yes? Yeah. I do a lot of swinging with the kids. All the time. Okay? So, as you watch this go back and forth, what's something you could measure about this?
How high it comes back up each time?
Yeah, I mean, you could actually think about it in terms of, let's say, an angle. So if I started here, if I pulled it back, let's say 20 degrees, you could let it go. Could you measure the initial angle? You could. What's something else you could measure about this? So we could measure the speed. Speed is actually a hard thing to measure because you would need some sort of speedometer, right? So you could, normally we don't really measure speed. All the time we like calculate speed, but I like where your head's at. Good. What else can we measure?
The height of the swing.
Yep. What else?
The length of the string.
Length of the string. Good. What else?
The weight.
Sure.
The bottom.
It says it's a 5 Newton weight. It says it right on there.
So it's 50.
What else?
Well, we could calculate how much gravity is pulling on it.
We definitely could calculate the gravitational force. All right? So the thing that I'm actually interested in today is what's called the period. Okay? So we're interested in the period. You guys know what the period is?
What's your favorite? Time to complete. Oh my god, that's
What's that? What's that?
Nothing.
So the period is the time to complete one full swing. So that would be from, let's say, all the way over here back to all the way over here. Okay? So, or it could be all the way from there back to there. Okay? We can't really go middle to middle because middle to middle, that's actually only half. You guys with me on that? You'd have to go middle going left, back to middle going left. So it's one full swing. We call that the period. And we use the capital letter T to represent the period. And we measure it in seconds per swing. Is that cool? We measure it in seconds per swing. All right. So Andrew, bust your phone out. Get the stopwatch out. What we're going to try to do is we're going to see if we can't figure out what the period of this pendulum is. Some people call this a pendulum. I've never seen a J in that word, so I usually call it a pendulum. All right. Are you ready? So you're going to start it and stop it whenever you want. And you tell us, say out loud when you're starting and stopping.
Go. Stop.
So that was probably pretty good. What was the time on that?
1.83 seconds.
So he says it took 1.83 seconds for this thing to go back and forth. All right? Now, that might be. The problem with a stopwatch like this is you got at least 0.1 error on the starting and another 0.1 error on the stopping. So this really could be anywhere between like 1.63 and like 2.03.
I got
right?
0.86. I got 1.86 for a second one.
Okay, that's good. That seems very reasonable. What we're going to do is I'm going to suggest a different way. What you're going to do is you're going to start it. We're going to let it swing 10 times. And then we're going to divide by 10. Because if we let it swing 10 times, the error is so much less compared to the total time.
Okay.
That makes sense? So you let it, you tell us when you're starting, I will count, and then we'll divide.
Start.
All right, so ready? This is 1, 2, 3, 4, 5, 6, 7, you're going to stop on 10, 8, 9, and 10.
18.33.
So this is great because we're going to take your 18 seconds. So to calculate the period here, we're going to take the total time, 18.33 seconds. We're going to divide by the number of swings, which was 10 swings. And what's cool about this is we get 1.83 seconds per swing, which is what you measured in your very first iteration. So that sounds great. Is that cool? Do you guys have a sense of how to calculate the period if you needed to? Does that look good? Fantastic. There's a related topic, okay? There's a related topic. That looks good. Okay? There's a related topic here. It's not the period, it's the frequency. Okay, so we're going to talk about the frequency. Now, what word do you see in this word frequency? What word do you see?
Frequent.
Yeah, you see frequent, right? I mean, the word is in the word. So the frequency is how often an event happens. If something has a higher frequency, it happens more often. Does that make a conceptual sense? Now, here's the thing. We're going to use a small letter f to represent frequency. And in this case, the frequency is the number of swings per second. It's the number of swings per second. How do you think the frequency and the period are related? Check with your neighbor on this one. What does your neighbor think? If you had to examine these two ideas in comparison to one another, how do you think they're related?
They both involve seconds and swings.
They both involve the time it takes for a swing. They both involve the time it takes for a swing. Thank you.
Love that. All right, how are these two ideas related? Yes?
I said it, they both measure the time it takes for a swing.
Well, this is the time it takes for a swing. This is, yeah, this is the swings per time. This is time per swing. This is swings per time. So, opposites, what does that mean? I think you're right, but opposite usually, opposite means something else. They're what?
Reciprocal.
Reciprocals is correct. So in this case, the thing that we're noticing here is if you want to calculate the frequency, you can do 1 over the period, or if you want to calculate the period, you would do 1 over the frequency. So if we were going to try to calculate this over here, we would do 10 divided by 18.33. What this means is that if you watch this, it only makes about a half a swing every second. It only makes about a half a swing every second. I mean, think about it. If you're just watching it, if it takes almost 2 seconds to go all the way there and back, how much of that does it do in a second? About half. Is that cool? So these two ideas are related, and we're going to need to understand how they're related for the next couple days. Is that cool? Is tomorrow Friday?
Yeah.
Already?
Yeah. We did have Monday off.
What's that?
We did have Monday.
We did, and it's freaking me out a little bit. All right, so watch this. I'm going to shorten this up. Okay. I'm going to shorten this up to here. And I want you to tell me, what happened to the period? What happened to the frequency? Did they increase? Did they decrease? What do you think? Compared to the original one, what do you think happened here? What are you thinking? Which one? I don't think they both increased. One definitely increased. Go ahead, John.
Period increase?
Does it take more time or less time to go back and forth? Yeah, so here's the thing. The time is actually less, so the period went down, but is it swinging more often?
Yes.
Yes, it is. So if one, because they're reciprocals, if one goes up, what has to happen to the other one?
So down.
It has to go down, right? And so we saw that by shortening this string here, the frequency went up, but the period went down. Is that cool?
Yep.
All right, we're going to need to have a good sense of frequency and period tomorrow.